Now let's go to properties of inverse function. So for the properties of inverse function, you should know that this is involving composite function. So if you compose f inverse with your fx, the answer is just equal to x. Okay, so since you have x here, f inverse composed with fx, the answer is x for every x in A, meaning that this is the domain for your f. Let's see another one. If you have f composed to your f inverse x, the answer will be equal to x for every x in B, because here we have drawn that for B to A, this is your f inverse, therefore this is your domain. Okay, so we can conclude here, if you have two functions, f and d, and when you compose both of them, you got the answer x. And when you flip it, d compose fx, this is also equal to x. Therefore, you can conclude that f and g are both inverse to each other. Now, let's see example 1. Let fx equal to 3x plus 5, then gx equal to x minus 5 over 3. So prove that f and g are inverse to each other. So what you should do is, let's just compose them. F compose g and also g compose f. If you got the answer x for both of the results, therefore f and g are inverses to each other. Now let's start first. Now let's try first f compose gx. So this is f, substitute gx first. Okay, just substitute inside. And then compose, so 3x plus 5. So this one can be cancelled out, and this can be solved. The answer is x. Now let's see the other way around, g compose fx. So you just write d and then put fx in bracket. Let's substitute this first, which is 3x plus 5. So now let us compose d 3x plus 5. So it is 3x plus 5 minus 5 over 3. So 5 minus 5 is 0, and then this is also can be cancelled out, 3 and 3. So the answer, again, you got the answer x. Therefore, we can conclude f and g are inverses to each other, since f compose t is equal to g compose f, which is equal to x. Now let's see another example here. Let fx equal to x squared minus 3, and this is for domain x more or equal to 0. And another one is gx equal to square root of x plus 3. So now let's prove f and g are inverses to each other. So first let's compose f compose g, then compose g compose f. Now let's do f compose g. So put f here, substitute gx first, which is square root of x plus 3. So now let's compose f square root x plus 3. So it is x squared minus 3. So square and square root can be cancelled out. 3 minus 3 is 0. The answer is x. Let's look at another one, g compose f. So this is g, and then substitute f, okay, and then let's compose g x squared minus 3. So it is square root of everything plus 3. So 3 and 3 can be cancelled out, and then the square and square root can be cancelled out. The result from here is a modulus x. And then we have clarified that x must be always more or equal to 0, so we can drop the modulus sign. So this is just x. So let us conclude f and g are inverses to each other, since f compose g is equal to g compose f. This is equal to x.